Welcome to iLecture Online, and here's another example dealing with momentum and impulse. We're concentrating on momentum right now. And here's an example where we're combining momentum with the conservation of energy. Excuse me. So let's read the problem, and then you'll see in just a moment how this is applied. We have a block that slides down a semi-spherical bowl without friction and collides with an equal mass block at the bottom of the bowl. They stick together, and presumably they'll continue sliding up the side of the bowl. And how high will the two blocks slide before they come to a stop? So let's make a picture, draw pictures here so we can see what's going on. Here's a semi-spherical bowl. We have a block with mass m that starts sliding from the top. There's a second block at the bottom, also mass m. When this block collides with this block, they will both continue to move forward because they stick together, so there's energy lost in the collision, and then they'll slide up and then they'll stop at some point. And the question is, how high above the ground will they be when the two blocks come to a stop? So how do you do that? Well, again, we start with the conservation of momentum, because we know that no matter what happens, no matter what the collision is, momentum is always conserved. So we can say that P initial equals P final. And we know that the momentum is the sum of the momentum of the first plus the momentum of the second. So we can say M1 V1 initial plus M2 V2 initial equals M1 plus M2 times V final. We can say it like this because we know that they're going to stick together, and there's only one final velocity of both blocks together. Now, this relates to the actual collision here. And so we can see that, that when they both collide, M1 V1 will be some value, but M2 V2 will be 0. This is 0 because the velocity 2, or the velocity of the second mass, is 0. So it wasn't moving when they collide. Now, let's see here. One more thing. What is the velocity initial when the first block collides with the block? Well, how do we figure that out? We weren't given that velocity, but we do know that it starts from up here, and there's no friction along the side of the bowl. And also realizing that the radius of the bowl can be represented by the letter r, which means that the first block starts from a height h equal to r. We can then say, well, the block gained kinetic energy by sliding down the block, down the bowl. So using the conservation of energy, we can say that energy initial equals energy final. And we can say that the energy initial would be mgh, potential energy, by it being up here, a distance h above the ground. And then when it hits the second block, it would be all kinetic energy would be 1/2 mv squared. So this v squared is, of course, then becomes the initial velocity over here. So this v squared is definitely that velocity right there. So let's solve for v there. We have an m on both sides. H is, of course, the radius of the bowl. So we have g times the radius is equal to 1/2 times v squared. And solving this for v, we multiply both sides by 2. And we take the square root of both sides, so v is equal to the square root of 2gr. And that can then go in here, so we can write that m times, and again, since m1 is equal to m2, right, then we can just call it m. So m times the initial velocity, which is the square root of 2g times r, is equal to the sum of the two masses, which is 2m times v final. And then you can see that we can cancel out an m on both sides. And we have the square root of 2gr equals 2 times v final. So v final can be expressed in terms of the square root of 2gr. Now that doesn't tell us how high the block will go. Well, we know that the final velocity of the two blocks will be equal to, if we solve for that, final velocity will be equal to 1/2 times the square root of 2gr. And then, after the collision, if we now take this part of the problem, after the collision, and use the conservation of energy to see what happens over here, we can then say that energy initial equals energy final. So what I'm doing here is, I first use the conservation of energy equation to figure out what the velocity is of the block when it reaches the bottom here and when the two blocks collide. Then I use the conservation of momentum to figure out what the velocity will be after the collision, and then I use the conservation of energy to see what happens after the collision over here. So energy initial would be the kinetic energy of the two blocks initial. That must then equal the potential energy that the two blocks gained when they reach the maximum height before coming to a stop. The kinetic energy would of course be 1/2 mv squared, 1/2. The mass would be the sum of the two masses, m plus m, and then the v squared would be the velocity that they both have right after the collision. So that would be the quantity 1/2 times the square root of 2gr quantity squared. So that's the kinetic energy of the two blocks right after the collision. And that will then equal the potential energy of the two blocks when they reach the maximum height. That would be mg, and we call that h, little h right here. There we go. Oh, and of course we have 2m because there's two blocks. Now we have m plus m on one side and m plus m or 2m on the other side, so these two cancel. We can then say we have 1/2 times this squared, so it would be 1/2 squared, times this squared, which would be 2gr, and that equals g times h. Then notice we have a g on both sides. We had a little accident there, but we'll just keep right on going. So we'll cancel out the two g's on both sides. This 1/2 cancels out that 2, so that cancels out, and now we have 1/4 times r equals h, and that would then be the final answer. H is 1/4 the radius of the bowl for the final height of the two blocks. So there's a good example. Let me review again. A good example of how to work with momentum and combine it with the conservation of energy. So here we have a situation where a block slid down the bowl. To find out what the velocity is when this block reaches the bottom, we use conservation of energy to do that right here. So we know that velocity is equal to the square root of 2gr, the radius of the bowl. So that would be the velocity that the block has when it collides with the other block. So now we use a conservation of momentum to show that the initial momentum must equal the final momentum with the collision. So right before the collision, the block 1 is the only one that has momentum, so it's m times v, v being 2gr. And after the collision, the two blocks stick together, so it would be the two masses together times the final velocity. We can solve that equation then for final velocity in terms of g and r. We then go to the situation after the collision, so then the two blocks are sliding up the hill, and they're then losing their remaining kinetic energy to potential energy before they finally come to a stop. We then use again the conservation of energy. The initial kinetic energy as the two blocks are sliding up the bowl equals the final potential energy when the blocks have reached the maximum height. Kinetic energy is 1/2 mv squared. The mass is the two blocks, and v is the v that we got from here. The velocity the two blocks have right after the collision is the initial velocity of the two blocks that are sliding up the hill. So since that's the final velocity after the collision, that becomes the initial velocity as they slide up the hill, and then equals the mgh, the potential energy, when they come to a stop. H is what we're looking for. Of course, there's two blocks, so we have 2m, and then we simplify that down to h being 1/4 r. It's a good example. Now we'll do a couple more of these to get you more of a feel of how to do these problems.